we could rewrite this demand equation, add P to both sides, subtract Q from both sides. And we could rewrite this as P equals 100 minus QD. If we write it this way with P on the left-hand side, technically the correct name for this is the inverse demand curve. Sometimes authors will just call it the demand curve, but technically it's really the inverse demand curve. Or the inverse demand function. And we could do the same thing to the supply curve. If we solve for P, we could rewrite this as, now all you'd have to do is add 20 to both sides. And we could write this as P, let's put P on the left-hand side, equals 20 plus QS. So this is really the inverse supply curve, or inverse supply function. Then our equilibrium condition again is QD equals QS, same as before. And let's just call this Q star. And if we solve this model, we should get the same equilibrium price and output, shouldn't we?
You got positive 20.
Yes, because our supply function, good question. Our supply function was this. So actually we'll add 20 to both sides. And now P is equal to, if we add 20 to both sides, we get 20 plus QS equals P. And now let me just rewrite that with P on the left-hand side. So now it is interesting that that intercept is now 20. But if we solve for this, we set QD equal to QS equals Q star, and we can just rewrite this as 100 minus QD. Notice you got a P here, you got a P here, so we can eliminate the P's. Equals 20 plus QS. Now, in equilibrium, QD and QS are the same. Let's just call Q star. So we could write this as 100 minus Q star equals 20 plus Q star. Add Q star to both sides, subtract 20 from both sides, and you get 80 equals 2 Q star. Divide both sides by 2, and you get Q star equals 4. Same answer we got before. Then you substitute into either the demand curve, the inverse demand curve, or the inverse supply curve, and you get P star equals 100 minus 40 equals 60. Same answers we got before. Okay, so you could do it this way, but I would prefer you to do it the way Chang does it. Let quantity demanded be and quantity supply be dependent variables. Measure Q on the vertical axis. If you wanted to look at, you wanted to graph P on the vertical axis, you would have to do this. You would have to use these equations. So our inverse demand curve looks the same as it did before, actually. Looks like this. Only we reverse the axes. But the supply curve now, as one of you noted, has a vertical intercept of 20. A slope of +1. The supply curve looks like this. Now the equilibrium quantity is measured off the horizontal axis. That would be 40. The equilibrium price is here. And this This is probably the way your bar used to go. Any questions so far? That's all for today.